Hello guys, welcome to Goodwill GATE2IIT. This is module 1, lecture 2. So in lecture 1, what I have done is we have discussed about the syllabus of aircraft propulsion, like axial flow compressor, turbine, jet propulsion, centrifugal flow compressor, rocket propulsion and all. So this lecture is basically on working and construction of axial flow compressors. And the next lecture most probably will be on velocity triangles. So if you understand these two topics, we can say that axial flow compressor we are good to go for GATE exam. Alright, and the complete understanding actually lies in working in construction as well as in the velocity triangles. So if you understand this, automatically a axial flow turbine is also done. So we'll see that. So before going directly into axial flow compressor, what it does and how it is producing pressures, let me go through few important points which we can discuss and then we can come to axial flow compressor. Alright, so first thing which I want you to understand is if I say axial flow compressor, so if you'll see this diagram, alright, so if this is, I'm trying to draw the TS plot for a basic turbojet engine. Alright, so on this side I am just drawing the schematic diagram. So we have a compressor which is connected through a shaft to a turbine, and then you have the outside cowling. So this is compressor, this is turbine, this is combustion chamber, this is diffuser, this is nozzle. So this is the very basic schematic diagram for a turbojet engine. So if I'll draw the cycle corresponding to it, so the air enters at this, we have diffuser, we have compressor, then you burn fuel, you go to knot 3, you have turbine, you go to knot 4, and then you have nozzle. Alright, so what we are doing in this particular lecture is the reason. So if you have doubt in this, perfectly fine, but we'll be discussing this everything in great detail in jet propulsion. The reason I'm going through what I'm doing is this: we'll be zooming this component, which is basically compressor. Alright, so we study about compressor, then we'll go for turbine, then we'll go for diffuser, then we'll go for nozzle, we'll study about combustion chamber, we'll combine them, we'll form a turbojet engine. We'll change few components, we'll form a turbofan, turboprop, turboshaft, ramjet, scramjet, all these engines. So just zoom this component. So today's lecture is basically what is happening inside this, so your pressure is more. So this is P01 line and this line is P02. Alright, so let me begin this. Axial. So what do you mean by axial? When I say axial, axial means your flow is moving in the axial direction only. So what happens? So if this is your aircraft, so let's say I'm drawing a very bad diagram corresponding to it. So if this is the aircraft and you're installing your engine somewhat here, alright, so this is the axial direction we have. I hope this is clear. Alright, so when we say axial direction, there will be no movement in the radial direction. That means flow will not move in the radial direction and flow will only move in the axial direction. So there is no, to be very specific, we should write this, there is no change of radius. Then you are saying axial flow, and in the end you are saying compressor. So what is the function of compressor now? The function of compressor is to increase the pressures. Alright, so axial flow, compressor, the main motive is to increase pressure. Now to focus on this pressure term, the function of any compressor, whether it is axial flow compressor or centrifugal flow compressor, your motive is to increase pressure. Alright, this is very important, which is the next topic I'm saying. So your motive is to increase pressure. Now it can be static pressure and it can be total or stagnation pressure. What is the difference between static and stagnation properties? Actually, which pressure you are increasing, which we want to increase, what is the phenomena, how they are increasing, that we need to discuss. Alright, so if I'll say static properties, this is P, let's say at some station, and this is P naught. Similarly, we have temperatures also, T and T naught. So the difference between static and stagnation properties we need to understand. If you understand this, working is clear for axial flow compressors. Alright, so before going into this, I want to show you one thing, which is this diagram. So I'm directly going into how your axial flow compressor will work so that it will increase pressure. So that if you increase pressure, you can burn fuel inside combustion chambers, which is actually you want. For this reason only you are using the compressor, so that you can increase pressures, and on this high pressure you can burn fuel inside combustion chambers. There will be proper mixing of fuel and air, and you will get high temperature rise, which is known as turbine inlet temperatures. Then you'll be having turbine, which is extracting some energy to drive major components like compressor, turbofan and propeller blades and all this. And then you have nozzle, and then you'll produce thrust in the forward direction. So it's somewhat complicated. Let's go into bits and pieces. So what is happening? Alright, so this is the basic diagram we have. So this is the shaft. On this shaft you have the rotor hub. This portion is known as the rotor hub. This portion, this black portion. On this rotor hub you are mounting few blades. I'll color them. So you are mounting few blades. These blades are known as rotor blades. The reason they are known as rotor blades, because they are rotating. You are mounting this on rotor hub, and rotor hub is mounted on shaft. So they rotate as a complete assembly. So this is rotating at a complete assembly. They are rotating in this direction. Now the another set of blades which you'll see, which are mounted on the outside cowling, means on this cowling you're seeing some blades, right? These blades are not rotating. So this reason these blades are known as stator blades. So you have one set of rotor blades, you have one set of stator blades, one set of rotor blades, one set of stator blades, and this goes on. Now in this starting point I have not done anything. This portion of blade, this blade which I have colored with blue now, alright, or let's say this portion of blade, this is inlet guide. These are known as inlet guide wings. So it is always not mandatory to have inlet guide wings, and as the name suggests, their function is to guide the flow so that the flow enters properly in the rotor blades. Why you want to do this, that we'll see, but I'm telling you, most of the problems which are asked in GATE exam, they're saying there are no inlet guide wings. So we should understand how your velocity triangles or the phenomena will change if I'll say there are no inlet guide wings, or if I'll say there are inlet guide wings. So we should know how it works. Alright, I hope this is somewhat clear. So to begin with the working, I'll just come to one important note. Alright, so you've seen the diagram. Now I'm going to summarize this. So the first set of blades which you always see are inlet guide wings. I can remove this also. The next set of blades which you'll see are rotor blades, and the third set of blade which you'll see are stator blades. Alright, so our main focus will be on rotor blades and stator blades. There might be a case then there are no inlet guide wings. So we will be discussing about this, but your main focus, velocity triangles, will be focusing more on rotor blades and stator blades. Alright, so let's see what is actually happening inside axial flow compressor. Alright, so let me zoom that diagram. Alright, so we have a shaft. If you understand this, velocity triangles are straight forward. Alright, so you have a shaft, something like this. on this shaft, I'm just drawing the portion of shaft on which compressor is mounting. The shaft is moving forward and you have turbine on this. Alright. So on this shaft you have rotor hub. On this shaft you have rotor hub. So this is basically, you can say this is a rigid body. This will rotate in this direction as a single body. So these are connected and it will something rotating like this. You have the outside casing which is stationary. You cannot move this. These are fixed. Alright. So anything which is mounted on the outside casing will be stationary. They are not moving. Anything which is mounted on the shaft or on the rotor hub are rotating. Alright, so as the name suggests, your rotor blades will sit on this and your stator blades will sit on the outside cowling. Alright, so let's install the first blade. So the first blade which is installed, I'm saying first blade which is installed are the rotor blades. The next blade which are installed are the stator blades, and then the rotor blades, and then the stator blades, and this goes on till this point. Alright, so similarly you have one rotor blade and one stator blade here. Alright, so the blades which are mounted on this section, all these blades are rotating. So these are known as rotor blades. And the blades which are mounted on the outside casing, they are stationary, right? So these set of blades are known as stator blades. So if you combine one set of rotor blade and stator blade, they together constitute a stage. Alright, so this is one stage. Again, one set of rotor and stator blades, you have another stage, and so on, and this is the last stage. Alright, so in the process you have let's say 5, 8, 10 number of stages depending upon the requirement, what pressure you want in the outlet. So each stage will contribute something in the pressure rise. In the end you will get the overall effect. So in the gate problems you will find like the overall pressure ratio of compressor is 5, the overall pressure ratio of compressor is 10. What are the number of stages required? Alright, so if you want 5 pressure ratio for the complete compressor, what the first stage is doing, what the second stage is doing, what the fifth stage is doing, how they are dividing this, that we need to do numerically, and we need to see derive some equation so that we can find what is the pressure rise in one stage. So I hope you understand what they mean by a stage. A rotor and a stator blade together will constitute a stage. What we are doing, why we are saying rotor and stator, why this configuration, now try to understand this. Alright, so what is happening, flow comes in this direction. Alright, and guys, keep this in mind, we are seeing the side view. So if you'll see from this side, you will see a circular section. That means you can see the circular cross section, the flow is entering, and these blades are actually distributed. So similar blade you have on this side also. Similar blade you have on this side. So these are circumferentially located. I hope this is clear. So this is the rotor, or you can say shaft. On this you have one blade on this side, you have one blade here, you have one blade here, you have one blade here. So if you see from this side, you will see something like ring of blades. I hope you can visualize. This is one blade, this is one blade, this is one blade, this is one blade, and so on. So what we are seeing is from the side view. So we are just analyzing what is this. So this one complete set of ring is together constitute one stage. Like so, all the blades. Let's say you have 20 blades on the profile. Let's say you have 20 blades of stator. So this 20 and this 20 together will constitute a stage. Alright, that we'll see. I'll go to show you some visualization so that you can see or you can feel how a stage or a rotor and stator blades looks like. Alright, so now see what happens. So flow enters in this direction. Now this is a very slow moving, very low energy air which is coming inside the aircraft engine, because we'll see, because we have a diffuser before this. Now what happens? This rotor is rotating at very large RPM. This rotor is rotating at very large RPM. So it is something like this. You have a rotor which is rotating like this at very large RPM. and actually this shaft is being driven by a turbine which is mounted somewhat here. So a turbine is rotating this shaft, and this shaft is rotating this rotor blade. So this rotor blade is rotating at very large RPM. So a very slow air is coming in this direction. So what you will do, you have rotating shaft, you have a blade which is mounting in this direction. So you have something like this configuration. So you have a shaft and you have a blade which is rotating in this direction, Alright, so let's see what happens. Air comes in this direction with a very low velocity. You are rotating in this direction and you hit the air. Alright, so air comes in this direction, your rotor is rotating in this direction, and you hit the air. When you hit the air, what happens? All the kinetic energy of the blade is being transferred to the air. So what happens? The kinetic energy is more now. So this is known as you are imparting the energy from rotor blades to the air. So the kinetic energy of the air is more now. Now what is your main motive? You convert this kinetic energy into pressure rise by any mechanism. If you do that, by the end of first stage, you will have the pressure rise. That is our main motive, right? To increase pressure rise, to increase pressure. So what is happening? Flow coming in this direction. In rotor blades, you are increasing its kinetic energy by hitting the air. And then in the rotors as well as in stator blades, you are converting this kinetic energy into pressure rise. I hope this is clear. So some pressure rise is accomplished in the first stage, then some pressure rise in the second stage, then some pressure rise in the third stage, and this goes on, and in the end you have the overall pressure rise. Alright, so in this way, this is the reason why we are using rotor blades, stator blades, rotor blades, stator blades. So hit the air, increase the pressure. Hit the air, convert this kinetic energy into pressure rise. Hit the air, convert this kinetic energy into pressure rise. In the end, have the overall effect of the compressor. Is this clear? Now, I just want to ask you a few things. First of all, you should answer this once all these lectures are done for axial flow compressor. Why the length of the blades are decreasing in this direction? This is asked in a GATE exam. So length of the blades, this is a longer blade and this is a smaller blade. So length of the blade is decreasing in this direction. This is the first question we should answer. Alright. Next question is, let me get the sheet again, then you can understand why I have drawn this compressor of more width than turbine. Next question, right? So this width I am asking why this width is more than turbine. This is the second question we should answer. Third question is why you are drawing your compressor in this fashion, like converging fashion, and turbine in diverging fashion. This is the third question you should answer. And the fourth which you should answer is which pressure you are increasing. Is it static pressure or stagnation pressure? And in the end we'll say a pressure ratio of 5 with the pressure ratio of 10. What pressure actually you want? You want static pressures to be high or you want stagnation pressure to be high? Keep this in mind. Alright, so I'll keep this lecture short. We'll discuss more in detail with the velocity triangles in the coming lecture. So I need to discuss inlet guide vanes also. So we will focus, once I'll draw the velocity triangles, we'll see what is the importance of inlet guide vanes and why we sometimes neglect and why we sometimes have inlet guide vanes, or what are the main motive. Now I hope you have a rough idea what is the main function of rotor and what is the main function of stator blades. So inlet guide vanes will guide the flow. Rotor will hit the air, so your air is now moving with more kinetic energy, and in stators you will convert this kinetic energy into pressure rise. You will also do this in rotors, but we will discuss this in separate module and we'll need to talk about degree of reactions in that. So how pressure is increased in the compressor? Air is coming, you are hitting the air, you're converting this kinetic energy into pressure rise, you're doing this in large number of stages, and in the end you have the overall effect. One single stage means you have one set of rotor blades and one set of stator blades. Alright, so we'll focus more on this, we'll discuss this in more detail. So if you have any doubt, you can always write to us at info@goodwillgate2iit.com. Alright, you can always call or message on the number which is displayed on the screen, and please provide your feedback for this video or for the lectures. Your feedback is always welcome. You can also visit our website, which is www.goodwillgate2iit.com. Alright, and please stay tuned for the next lecture. Try to just go through this topic and lectures, and if you have any doubt, you can message us. Alright, so we'll meet in the next lecture. Stay tuned. Bye bye. Thank you.